I bet you didn't know why your software fails. Picture this. It's payday, and you're eager to check your balance. You open your banking app, excited to see those hard-earned dollars. But instead of your balance, you're met with an error message. Frustrating, right? We've all been there. Software failures can be incredibly annoying. We rely on software for everything. When it fails, it impacts our productivity and peace of mind. But why does software fail? The answer lies in understanding checking and testing. Let's dive in and explore these concepts. Imagine a bustling car factory. Each station along the assembly line has a specific role: welding the chassis, installing the engine, attaching the doors. At each stage, meticulous checks are performed to ensure every component meets precise specifications. Is the weld strong enough? Is the engine properly aligned? Are the doors fitted correctly? Checking, in the context of software development, shares a similar principle. It's about verifying that the software, like the car on the assembly line, is being built according to the plan. It involves examining specific aspects of the code, often in isolation, to confirm they meet predefined criteria. Are the calculations accurate? Is the data being stored correctly? Can the user log in successfully? These checks act as quality control checkpoints, ensuring that each piece of the software puzzle fits together as intended. They are essential for catching errors early in the development process, preventing them from snowballing into larger problems down the line. Think of it as catching a loose screw before it causes the entire car to fall apart. One of the powerful aspects of checking is its potential for automation. Just like robotic arms on the car assembly line can perform repetitive tasks with precision, automated tools can execute a battery of checks on software code quickly and efficiently. These tools, often referred to as static analysis tools, can scan thousands of lines of code in seconds, flagging potential issues related to coding standards, security vulnerabilities, and even potential bugs. Automating these checks frees up human developers to focus on more complex and creative tasks. It's like having a team of tireless inspectors working around the clock, ensuring that every line of code meets the required standards. This not only speeds up the development process, but also enhances the consistency and accuracy of the checks, reducing the likelihood of human error. However, it's crucial to remember that automation has its limits. While automated checks excel at verifying specific aspects of the code, they can't capture the nuances of how the software will behave in the real world. This is where testing comes into play, taking us beyond the controlled environment of the factory floor and into the unpredictable landscape of user interaction. Imagine taking that newly assembled car out for a test drive. It's one thing to know all the parts are in the right place and functioning individually, but it's another to experience how they perform together on the open road. Does the car handle well around corners? How does it perform at high speeds? Is it comfortable for passengers? Testing in the realm of software development mirrors this real-world evaluation. It's about exploring how the software behaves under various conditions, simulating user interactions and scenarios to uncover potential issues that checking alone might miss. This could involve testing how the software responds to different input values, how it handles unexpected user actions, or how it performs under heavy load. Unlike checking, which often focuses on individual components, testing takes a more holistic approach, examining the software as a complete system. It's about putting the software through its paces, pushing its limits to see how it holds up. This helps identify potential problems that might not be apparent from simply inspecting the code, such as usability issues, performance bottlenecks, or unexpected interactions between different parts of the software. Testing is not just about finding bugs. It's about building confidence in the software's ability to meet user needs and expectations. By simulating real-world usage scenarios, testing provides valuable insights into how the software will perform in the hands of users. This information is crucial for identifying areas for improvement, refining functionality, and ultimately delivering a better user experience. Think about it. You wouldn't buy a car without taking it for a test drive, would you? Similarly, relying solely on checking without thorough testing is like assuming a car will run perfectly just because all its parts have been individually inspected. It's a risky approach that can lead to costly and frustrating problems down the line. Testing allows us to catch these problems before they reach the end user, ensuring that the software we release is not only functional, but also reliable, usable, and enjoyable to use. It's about shifting our perspective from simply building software to building software that works and works well for the people who matter most, our users. Section 6. A real-world reality check. When checking isn't enough. Let's return to our banking app example. Imagine the developers have implemented rigorous checking procedures. They've used automated tools to scan the code for errors, ensured all the calculations are correct, and verified that the login functionality works as intended. From a checking standpoint, everything appears to be in order. However, upon release, users encounter a critical issue. The app crashes whenever they try to access their account balance on a Monday morning. What went wrong? The checking procedures, while thorough, failed to account for a real-world scenario, a surge in user traffic at the start of the week. The system, designed to handle a certain volume of requests, buckles under the increased load. This example highlights the limitations of checking alone. While crucial for catching errors in isolation, checking cannot fully replicate the complexities of real-world usage. It's like checking the engine of a car without considering the transmission, the brakes, or the tires. All the components might be functioning individually, but the system as a whole might still fail. Section 7. The power of both, combining checking and testing. The key takeaway here is not that checking is unimportant. It's that checking and testing are complementary activities, each playing a vital role in ensuring software quality. Checking, like a meticulous inspector on the assembly line, ensures that each component is built to specification. Testing, like the test drive, evaluates how these components interact and perform in real-world scenarios. Think of it this way: checking is about verification, while testing is about validation. Checking verifies that the software is built right. Testing validates that it's the right software for the job. Both are essential for delivering software that is not only functional, but also reliable, usable, and fit for its intended purpose. By embracing both checking and testing, we create a more robust and comprehensive approach to software development. We catch errors early in the process, identify potential problems before they impact users, and ultimately deliver a higher quality product that meets user needs and expectations. Section 8. Checklists, your first line of defense. Now that we understand the importance of both checking and testing, let's explore a practical tool that can help us implement these concepts effectively. Checklists. Checklists might seem like a simple concept, but they are incredibly powerful tools for ensuring consistency and reducing the likelihood of errors. Think of checklists as your first line of defense against common software failures. They provide a structured way to document and verify essential tasks, ensuring that nothing falls through the cracks. Just as pilots use checklists before takeoff to ensure all systems are operational, software developers can use checklists to guide their checking and testing processes. These checklists can cover a wide range of areas, from coding standards and security best practices to common user scenarios and performance considerations. By incorporating checklists into your development workflow, you create a safety net that helps prevent routine problems and ensures that your software is built on a foundation of quality. Section 9. Building your checklist. Practical steps for success. Effective checklists focus on critical and impactful items for your project. Define your scope clearly. Identify critical tasks. Prioritize and refine your list. Keep it concise and actionable. Iterate and improve regularly. These steps ensure software quality and reduce errors. Section 10. The road to reliable software. A continuous journey. Building reliable software is not a destination. It's a continuous journey of improvement. By embracing both checking and testing, and by leveraging practical tools like checklists, we can make significant strides towards creating software that is not only functional, but also robust, reliable, and enjoyable to use. Remember, it's not about achieving perfection, but about striving for excellence. Every bug we find, every issue we address, and every lesson we learn brings us one step closer to building software that meets the needs of our users and enhances their digital lives. So let's keep this in mind and subscribe to CheckOps for more content and videos.